Hello everyone. In the previous video, we have seen a number of informed search algorithms like greedy best first search algorithm, A-star algorithm, and ID A-star search algorithm. We have seen that greedy best first search algorithm is not complete and optimal, and whereas A-star search algorithm was complete and optimal. But one of the limitation of A-star algorithm was huge memory requirements, and we have seen one of the technique to solve that, which is IDA star search algorithm. In IDA star, we have seen that we require only linear memory requirement, and therefore and also retains all the advantages of A star algorithm like completeness and optimality. We have one more algorithm which is also a memory bound heuristic search algorithm called as recursive best first search algorithm, which also have the advantage of having lesser requirement of memory, and thereby the space complexity becomes order of n, which is linear. So let us see the recursive best first search algorithm. So it is a simple recursive algorithm that attempts to mimic the operation of standard best first search but using only linear space. So it retains all the best first search algorithms properties, but it is recursive in nature, and also it achieves the linear space requirement. Recursive best first search is similar to recursive depth first search, where it goes deeper and deeper, except that we have something called as f limit, which keeps track of the f value and also f value of the best alternative path. So apart from the f value of the current node, we also keep track of the best alternative path. This we do it for a particular purpose where we need to go back if at all if we fails in the current node expansion. So it always keep a backup of the second best alternative path which it can pursue. So every node has its f value and also an alternative path f value. So this is what I was saying. If the current node exceeds this limit, the recursion unwinds back to the alternative path. So since we have stored the alternative path f value, and if at all if the children expanded, if the nodes after expanding the node, if we found to be having f values which are greater than the limit, we can always go back to the alternative path. And when we are going to the alternative path, the current nodes values will be backed up with the least f value of the children. So we'll see one example to get more clarity of how recursive best first search algorithm works. So RBFS is somewhat more efficient than IDA star algorithm, but it also suffers from the successive node regeneration. We will see about what are the why IDA star and RBFS doesn't utilize more memory in the coming slides. So let us see one example of how RBFS algorithm is implemented. Let us consider this node A, and we use a value on the top of the node as a limit and on the bottom of the node as the cost value. So current node A has 366 as the f value and infinite as the limit. So the node A has expanded and generated the children B, C, D, which has f values 393, 447 and 449. As you can see, 393 is the node B has the lesser f value, but it also retains or it also stores the best alternative path. Here the best alternative path is node C. So the f value of node C is also kept on the top of node B. So node B has f value 393 and the best alternative path is kept in the top of the node B. So now node B is expanded and we generate the children. So we have node E, F, G, H, which have the f values as 646, 415, 671 and 413. Among that, node H has the least f value, and also it stores the best alternative path. So the best alternative path is node F. So node F value is 415. So node H keeps track of its F value, which is 413, and also the best alternative path, which is 415. So now node H is once again expanded. Here we have I, J, K nodes. Among that, node J has least, but the thing is node J has F value which are greater than the F limit, which is 415, and therefore we don't pursue anymore the children of node J. So and we now in fact replace the node H F value to the least F value of its children, which is node J. So here node H value will be updated to 417. This 417 we got because node J had 417 as the F value. Now we pursue the alternative path because we are not able to get the least cost using the node H. So the alternative path is node F. So we pursue node F. We have L and M as children. So 591 and 450 are the two nodes. Here once again we come to know that node M has a higher cost than the cost which we already have it. So once again we stop pursuing node F and we update the node F with its best value of its children, which is node M F value, which is 450. So and also we keep track of the alternative path for node F, which is 417. So we once again pursue this node H because now the node F value is 450. So we pursue node H. So node H has children as I, J, K, where J has the least cost, which is 417. And we have also updated the best possible alternative path, which is 447, which is coming from node C now. So now node J will be expanded further and we reach to the goal node with the cost 418. So in this way, recursive best first search algorithm keeps track of the alternative best path and it expands only if it is having lesser F value, and if there is an alternative path which can give the better F value, it pursues that and it keep on toggle based on the F value. So as compared to IDA star algorithm, we don't iterate from the very beginning. We keep on move to the alternative path based on the F values. So this is how recursive best first search algorithm works. This also require a linear memory because it forgets every other node when it comes to know that it does not give a better path. So the only values it remembers it is the alternative path F values. So this is one of the memory bound heuristic search technique which solves the problem of memory requirement which was there in A star algorithm. So these are some of the points similar to A star. RBFS is also optimal. It requires linear in depth. Space complexity is linear. Both IDA star and RBFS suffer from what is called as using too little memory. Suppose if you are having a huge memory, it does not utilize the memory completely. Although both IDA star and RBFS require very less memory, but if you have a memory, it does not exploit that memory, and that is also considered as a disadvantage. So RBFS retains more information in memory, but it uses only linear space even if more memory is available. So and they suffer the potentially exponential increase in complexity associated with redundant paths. If there are redundant paths in graph, then also the complexity increases. So these are some of the advantages and disadvantages of recursive best first search. So it maintains the optimality and completeness which are there in A star algorithm. Space requirement is less, but in terms of memory usage when it is available is not so good. So there are two other algorithms which utilizes the memory more effectively. These are called as memory bounded A star, MA star, and SMA star, simplified MA star. So here we discuss SMA star. So SMA star, similar to A star, expands until the best leaf, expanding the best leaf until memory is full. So it utilizes the memory more effectively. So SMA star is slightly better in terms of utilizing memory as compared to IDA star and recursive best first search algorithm. So the algorithm goes something like that. It expands similar to A star until the memory is full. Once the memory is full, it drops down the worst leaf node, which has the highest F value, and whenever memory gets filled, it drops down some of the nodes which are having highest F value. So that's how SMA star algorithm works. Thereby it utilizes the memory more effectively if we have the memory. So this is one of the other algorithm which also comes under the memory bounded heuristic search algorithms. So in summary, these are the algorithms which we have seen in informed search algorithms. We have seen greedy best first search. It is not complete, it is not optimal. Time complexity and space complexity are both high, where B is a branching factor and D is the depth. A star algorithm is both complete and optimal, but there are few conditions for completeness and optimality. For optimality, we have admissibility and consistent, which we have seen. Time complexity is higher in worst case, but it depends upon the heuristic function we have chosen. Space complexity is huge in A star algorithm. IDA star algorithm, space complexity substantially decreases. It becomes linear. It is also complete and optimal with the same conditions as A star algorithm. And the only slight disadvantage is it iterative, which means that it repeats, it traverses along the nodes multiple times, and so that is the advantage and of IDA star algorithm. So we have recursive best first search algorithm, which also has a linear memory requirement. Completeness and optimality is guaranteed similar to A star algorithm, but IDA star and RBFS utilizes less memory when the memory is available. And to overcome that, we have MA star and SMA star algorithms, which utilizes memory more effectively. So this is a summary of all informed search algorithms, which comes under the category of search algorithms, broad category of search algorithms. So in the next video, we'll be seeing adversarial search algorithms. Thank you.